Okay, today let's go over Coding Club Set 3. Starting off, the first question, what will be the value printed by x? So we have if 2 is less than 1, and then we have a semicolon, else x equals 2 less than 0. And if that's the case, we print f, otherwise we print f4. Now, this almost looks like just a normal if else. However, we notice that there's a semicolon right here. Now, what will end up happening when this code is run is it will evaluate this to false. And normally without the semicolon, it'll then default to the else statement and execute this line. However, because of this semicolon, it'll just evaluate to false, and then it'll just stop at the program right here, and it will never actually reach the else statement. So the answer here is, as you can see, is D, none of the above. Okay, and now question 2. The following program fragments outputs an integer that is same as which option? Okay, so it looks like we are just evaluating this simple for loop here. We have x is 4, y equals x, so y is also 4, and then initialize I. From I equals 1 to I is less than 4. So from 1, 2, and 3, so I is its 3 iterations, we add x to itself. So we essentially multiply x by 2. So the first loop, x will be 4 plus 4 is 8. The second loop will be 8 plus 8 is 16. And then when I equals 3, we have 16 plus 16 is 32. So by the end of this, x will equal 32 and y equals 4. So now we need to figure out which one is correct here. So as you can see, the value of x is 8 times the value of y. So we have A as the answer. The next question here, what will be the output? So like one quick thing we need to understand before looking at this is the concept of scope. Now, scope is basically basically our way of defining what is available and what is outside, or what is not available in code. If I have a certain bit of code underneath these curly braces, then only variables defined within these are, if there's anything defined and then we are outside of it, then we no longer have access to this variable. So if we have like int I, int j, these are only accessible within these curly braces. So that's scope right there. So let's take a look at the question. So we have integer, we have I set to 2, and then they define a set of curly braces here, one step lower, defining or redefining I and j. And then we print out I and j, which that looks correct because, again, because we're in the same scope, we are allowed to print out I and j. However, outside of the scope, we tried to do that again. And in this case, we have I would actually be 2, but j is not accessible from this line. So the program will actually not compile at all. Okay. So what will the following program output print? So one quick rule in C and C++ is if you want to do these large plus type of evaluations, we're going to have to use parentheses in order to tokenize the value. Otherwise, the compiler doesn't really know what is happening here. So the compiler will get confused when it groups the tokens into into the expression. So this is actually an incorrect way to kind of add it plus plus over and over again at the same line. So the answer here, it will be D, none of the above. Now to fix this, we would have to use parentheses or some sort of variables in order to explicitly tell the compiler which exactly step by step we're adding A and B. Okay, so for this next question, we have a main that calls this function 3 times. And then the function itself, it creates a static variable, and then it prints out the variable and increments it by 1. So one important thing to remember about static variables is that they are, it preserves the value each time we call it. So a static variable is a variable that's kind of global within the same class. So in this case, the value of X will actually remain after each increment. So the first time X is initialized to 0 when we call this line, and then we print F and we increment it. So it's going to print 1. And then when we call again, because the variable is static, the value of X is still like remains, and then it'll print 2 and then 3. So answer is B. Next question, what will be the result of the following code segment? So we have a while printf, and then inside that we have the number operator and then printf of AZ. And then last line, we want to print by. So let's take this step by step. So let's start at the innermost part, which is this printf AZ. So as we all know that what that will do is it will print out AZ onto the console. And then one important thing to know about printf is that the return type is the size of the string that it prints out. So printf AZ will evaluate to 2. So that actually evaluates to a number, as well as printing to the console. So what's going to end up happening is this will equal 2. It will print out, and then this will equal 2. So now we essentially have printf 2, which will print out the number 2. And because this is a positive number, because this value will always equal 2, what will end up happening is the while loop will be stuck in an infinite loop of just printing out. It'll just print out like infinitely, because it'll be stuck in it, and then the value of printf this and that will always equal to a positive number. So because of that, the answer will actually be none of the above, because it'll enter a infinite loop. Okay, question 7. We have some integer num. So it looks like we have a recursive problem. And if you remember anything about recursive functions, it's that they're functions that call themselves. So we have if num is not 0, then we call this, which is a recursive call. And then otherwise, we want to return the number itself. Okay, so the best thing to do when we evaluate recursion is to take it step by step each way down until we get to the base case. So the base case here is basically if the number equals 0, then we can finally exit out of the recursive calls and then start working back. So let's just take it step by step. So we have sum 4 equals, and this is what we're trying to evaluate. So what does sum 4 equal? This equals Well, 4 is not equal to 0, so we enter this if statement. So we have equals 4 because num is 4 right now. So 4 plus 4 times sum of 4 minus 1 is 3. Okay. So what is sum 3? Let's evaluate that. Sum 3 equals 3 plus 3 times, now we go down one more, sum 2. What is sum 2 equal to? Equals 2 plus 2 times sum of 1. And now lastly, what is sum 1 equal to? Equals 1 plus 1 times sum of 0. So, and now we're at the point where we can actually evaluate what sum 0 equals to, because as you can see here, when num equals 0, then we return 0 if it equals 0. So this will hit the else and return 0. So this will actually be 0. So now we can start working backwards. 1 times 0, so 0, and then 1 plus 0 is 1. So sum 1 equals 1. So let's go back to sum 1. This equals 1. 2 times 1, 2, and 2 plus 2 is 4. So sum 2 equals 4. Place that. Now we have 12 here, and 3 plus 12 is 15. And now we have sum 3 is 15, so we can replace that with here. And now we have this final statement, which then eventually equals to 64. So we have C as our final answer. Okay, so we have the following C function takes a singly linked list of some elements. The function is called by the elements 11, 12, 13, 14, 15, 16, 17 in that order. What will the contents of the singly linked list be after you implement a code and execute the function? Okay, so let's take a look. So we have the basic node right here, just a value and then a pointer to the next. And then the function itself, it looks like if anything is null or if it's a size 1, then we just want to return it. Otherwise, we have two variables, m and n. So m will keep track of the starting, and then n will keep track of the next. So while n is not null, and then this code right here essentially will just flip m and n. So for example, when we start out, the 11 and 12 will be swapped. Now it's asking for the code to be implemented. So the way to solve this would just be to do a dry run for every single code fragment here, and then to see what the output prints out and see if they match up. And if you do this for every single one, you're going to end up getting D as the correct pairing between the code and then the output. And to illustrate that, we can go over that really quick. So we have m equals n dot next. So let's just write out the given codes 12, 13, 14, 15, 16, 17. So in the beginning, we have m is set to this pointer at 11, and then n is 12. So the first thing we're going to do is we're going to swap these two. And then we're going to say m is n dot next. So remember, n is here. So n dot next will be 13. So now m equals 13. And now n equals m dot next. So because m is 13, n will then equal 14. So now m is this and n is this. So once again, we swap. Okay. And now we do the same thing where we put m as the next and n as here. So this becomes 16 and 15. And now m is 17 and n ends up becoming the null value because we reached the end. So this will actually exit out the while loop successfully, which leaves this as the final contents. And as you can see here, this matches up just like this. Okay. So next we have Sahili, a budding coder, has been given a task to find the minimum sum of products of two arrays of the same size. Sahili was said that she can perform k number of changes on the first array, whereas in each change, the value of any one element of the first array can go up or down by 2. She writes the code like the following. Okay, so all this code up here is just defining the input. So we have A, which is an array, and then B, and then we just scan and get the info here. So now looking down in this code, what this code is doing is it's just finding the max element of array B and determining what index, or in this case, position it is. So let's think about exactly what we're trying to accomplish. So we're trying to find the minimum sum of products. So just like as you can see on the last line here, we want to find the sum where we add up the A of I times the B of I. And the task here is we're trying to minimize that as much as possible by performing some operation of k number of changes on the first array. So let's think about exactly what that means. So in this case, if we have two numbers, right? Let's say A of I and then B of I. If you want to minimize, so we'll actually, this will be times, right? Because we're trying to find the products. So if we want to minimize the result of this, that means that we want to have at least one of these be negative and then the other ones be the biggest positive. Because, if you multiply two numbers, like the bigger the numbers, the bigger the product. And since we want to minimize that, we only want to have one of these be negative. So what does this mean for our code? Well, as you can see here, the answer is C because we have B, right? So if the biggest absolute value of B, if that is actually negative, then we want to make A the biggest possible by adding 2 times K. Why? Because if B is negative, then we want to, in order to get the most smallest sum of products, we want A to be the biggest positive number. And then vice versa, if the maximum value of B, if the absolute value of the maximum value of B is positive, then we want A to be the smallest number to maximize, or I guess to minimize the total sum. So because of that, we go with this line of code. And now let's evaluate what that means. So now we can kind of illustrate what that looks like. So looks like they give us some numbers here. So we have A equals 1, -3, and 2. B equals -3, -5, and 2. K equals 6. So let's go through the code using this input and see what I'm talking about. So first thing we do is we want to go through B, iterate through the entire contents, and determine what the max value of B is and store that in as an index. So after going through all of this, we find out that the lowest value, or I guess the biggest absolute value, is -5, which is position at 1. So pos equals 1. Okay, so now we want to, just like I said, if b pos is less than 0, which in this case it's -5, then we want to maximize this value. And how do we do that? We add 2 times k. Now k is 6, so that's -3 plus 2 times 6. So this is 12. So -3 plus 12 is 9. So again, we want to increase a by as much as possible because we have this as the lowest negative number. So now when we do the sum of the sum calculation down here, we now have 9 times -5 as -45, which is the lowest possible product in that case. So let's evaluate that. So the sum will end up being equals 1 times -3 plus 9 times -5 plus 2 times 2. So that is -3 minus 45 plus 4. And if you math that out, that will equal 44. So getting the sum will actually be the difference between this and option B, because both B and C have the same code, but they have different outputs. So in order to differentiate which one is the answer here, we have to go ahead and perform these calculations. So with that being said, we have C as our answer. Okay, well, that will conclude the review for coding set 3. As always, we have our YouTube with all of the uploads of these, and then as well as everything can be found on the website on this URL.